welcome back. This is Mr. Steele, and I'm going to go through standard quiz question number 8. So, in my opinion, this is probably the most difficult standard on the standard quiz for Term 3 in Pre-Cal, only because it's the one where it just takes so much precision and so much care, and there's only that little bit of space on the standard quiz, and so it's really a matter of first taking the information that they give you in the problem and using it correctly. But also it's about being precise and being careful and not rushing through it. So this is another one of those standards like number 6 where I think you know how to do it. I mean, you proved you could do it during term 1, but you just have to be careful as you're going through it. So first though, let's go through a little refresher on 8. So I'm jumping right ahead into, not the hardest version, because if we ask for a degree 4 one, it takes a lot of work, but just a degree 3 polynomial. So, and it's got zeros at -2 and 3 minus I. So last term we went through this, talking about the fundamental theorem of algebra, talked about the fact that the number of zeros has to match the degree of the equation. So since it's degree 3, I've got to have 3 zeros. So now if you notice, 2 of them are given to me, -2 and 3 minus I. But that's not all. I have to have a third one. And now it could be a double root, so it could be another one at -2, or it could be a conjugate. Well, in this case, since we only have one more spot, it has to be the conjugate, the complex conjugate of 3 minus I. So in this case, our next zero, or our third zero, our final one, would have to be 3 plus I. So that's a good place to start, is make sure you have the correct zeros. Now, we need to take them and turn them into factors. So these are the zeros, we need to write the corresponding factors. So each time we write a corresponding factor, it's going to be x minus k, where k is the 0. So in this case, when I write this out, I'm going to have x minus a -2 is x plus 2. And now for this next one, I'm going to actually do a second step here and write it out carefully. So it'll be x minus something and x minus something else. So in those two spots, I need to have my 2 zeros. So it's going to be 3 minus I and, of course, 3 plus I. Now you might wonder why I'm going to do this extra step here, but the reason is I saw a lot of people on this last week's standard quiz not correctly write the factors. You know, they'd see this kind of piece, they'd see the piece with the complex number, but then they'd have like a -3 plus 3. But if you notice here, when we actually go to rewrite this, we're going to have x minus 3 plus I, x minus 3 minus I. So in fact, it'll be -3 both times. So that's one place that you can throw yourself off early in the early going. Okay, so here, our second step, x plus 2. This will be x minus 3 plus I. So again, I'm just kind of distributing it in. And then over here, we're going to have x minus 3 minus I. Again, distributing it in. And okay, once we get to this point, we're set to start doing the actual hard work. Because, you know, if this was just the end of it, I mean, we'd already be done. But we don't want just the polynomial in factored form. We want it written out in terms. We want to see all of the terms of this guy. So to do this, we use a little trick that we call kind of the manufactured difference of squares, or hidden difference of squares. And that is, we see that in both of these factors, we have an x minus 3, and we have an I. So something plus I, something minus I. So that means we can actually simplify it using a difference of squares. So going on to my next step, or my next line, I'll keep using this color, we actually are going to use that to our advantage. So we can actually turn these two factors into x minus 3 squared minus I squared. So that's actually pretty cool. That saves us a lot of work, because otherwise we'd have like this huge box, or we'd have to be multiplying 3 terms by 3 terms. That takes forever. This is a much nicer piece. So from here, we need to simplify this guy first before we can start multiplying things out. So to do that, let's first keep this guy here. To do that, I need to know what x minus 3 squared is. And now I know perfect squares in my head, so I'm not going to write it out over here. But obviously if you need to, you can always do x minus 3 times x minus 3. But I know this is going to be x squared minus 6x plus 9. And now, careful here, this is going to be minus I squared. Well, I squared is -1, so it's going to be minus a -1. So that means that since this is minus a negative, it'll be plus. So what we really have to multiply out is x squared minus 6x plus 10. And so there we go. We've gotten to the point where we just have to multiply now. So now, you might be thinking at this point, Holy cow, that's a lot of work to not even be at our final answer yet. And to which I would reply, yeah, it is. Alrighty, so now though, even though we're not yet finished, we're really just one step away from finishing, and that step is really just an Algebra 1 step. We've got to multiply these two binomials together. So there are a lot of different strategies to do this. I personally like stacking them and doing it the third grade method, but since I think most of you, from what I see on your paper, use the kind of FOIL method or kind of the extended FOIL method, I'm going to use that one. So this one's not terrible, it's not degree 4, so it'll help, but what I'm going to do is I'm going to multiply x times all these terms, then I'm going to do 2 times all those terms. So first one, be x times x squared is x cubed. And again, this is that place where you might have done all the good work up to here, but if you screw up one little sign or one little multiplication, you're in trouble. So x times x squared is x cubed. Then we've got x times negative 6x. It's going to be negative 6x squared. Finally, it's going to be x times positive 10. It's going to be positive 10x. And now you might notice here when I go and write my second row, I'm going to be really careful with where I do it. I'm going to line up like terms here. So positive 2 times x squared is going to be plus 2x squared. Positive 2 times negative 6 is going to be negative 12x. And last, it's going to be positive 2 times positive 10 is positive 20. And so there we go. We've kind of written it all out. Now we've just got to combine like terms and add these puppies up. So here we go. I'm kind of excited. So going down, x cubed. Then we've got minus 6 plus 2 is going to be negative 4x squared. Notice I'm being careful here. Positive 10 minus 12 is going to be minus 2x. And then plus 20. So I think that this is going to be my answer. Now, on standard quiz, if I was actually taking this right now, aside from the fact that I wouldn't be talking, I wouldn't be able to check it on TI-83, but I actually grew up and took all my math in high school with a TI-86, so I happen to know that the 86 has a way of checking this sort of thing. So I'm going to just show it to you now just to verify that we actually found the correct answer. And so no one in here has a TI-86, which is fine, but on the 86, right above program is a little button that's there, a little second thing that says poly. That's for polynomials, so you can actually kind of find the polynomial orders. And so what I'm going to do here is I'm going to punch in the degree here. So my degree is 3, so it's of order 3. And now it wants the coefficients for each of the terms. So in this case, I found it was 1x cubed minus 4x squared minus 2x equals 20. And just so you know, I haven't actually checked this up to this point, so I have no guarantee that this is actually correct. So I'm hoping it will be. Here we go. Hopefully what we'll see is indication that our 3 zeros are what we found them to be before, right up there. Okay, so what this shows me is this kind of a weird notation. It looks like they're giving us ordered pairs. Well, that's just because on the TI-86, when they use complex numbers, they give them in terms of like coordinates. So 3, 1 is 3 plus I, plus 1i. 3, negative 1 is 3 minus 1i, so those two are both there. Then the last one is just negative 2 plus 0i, or just negative 2. So in fact, according to the TI-86, a tool that I happen to have, this actually works out. We found the correct answer. If you were to try and check your answer on the actual standard quiz, you might, I guess you could graph it and try and see if the real root is there, but there's really not an easy way to check it. You just have to be careful as you go through each of these steps. And again, even in that little bit of space, try to be as careful as you possibly can going through. Okay,